And hello, everybody. Professor Andy Molnar, and I am here with you. Since this week I asked you to comment a little bit about artificial intelligence, I wanted to give you kind of an artificial intelligence 101 version, right? It's a little deeper than some of you want. Don't worry about it. It's maybe not as deep as others would want. Okay, for further study, I offer it up to you, but it's meant to be in the middle, just a general understanding. Don't take a lot of notes. Just think about what's going on in artificial intelligence so that you can form your own concepts of technology that transforms and apply it in the world that you live in. So basically, just enjoy the process right now. So, we start by asking ourselves, hey, what is AI, right? It's a good question that we want to make sure that we understand and can grasp. So, artificial intelligence, it refers to that development of these computer systems that now can perform a lot of tasks that typically required some human intelligence along the way, right? And these tasks range broadly from learning from experience. They also, AI incorporates an understanding of our language. When I say our language, the human languages is what I really mean. And so it recognizes patterns as well, solves problems, and frankly, will even make decisions for us. Now, there are a lot of kinds of AI. We're going to go through those here in the next few minutes. And so, but just to kick it off, right? There's something called narrow AI, right? That's kind of a weak AI. And narrow AI is designed to perform, frankly, narrow tasks, right? Like facial recognition or internet searches. And this is really the most common use of AI today. We have then strong AI. That's really just general AI, is how a lot of people see it. We don't normally think of a search engine as AI, but it is. And you can see that more and more in the results it produces. But now general AI is strong AI. This is a more advanced form of AI that can understand, it can learn, it can apply intelligence across, frankly, a wide range of tasks, frankly, just like a human being, right? This is AI that is in development right now. There's also super intelligent AI. This is, frankly, a theoretical concept at this point where AI surpasses human intelligence and it can perform, frankly, any intellectual task that a human can do, right? There is much debate on this super intelligent AI and concern within the field of AI itself for super intelligent AI. AI systems can be, and then so based on those three concepts, narrow AI, general AI, super intelligent AI, we can then apply other words that we commonly hear with AI, like machine learning, right? We'll talk about deep learning. We'll talk about the natural learning process. The natural learning process is exciting because it's a field of AI that is focusing on the interaction between a computer or computers and humans through a natural language, right? It allows the machines itself to understand, interpret, and then frankly generate a response in a human language. And so if we think we can avoid AI, we can't. It's already used in various applications today, from virtual assistants like Siri and Alexa. Even if you have a self driving car, you're using it. Medical diagnosis uses it. Financial traders use it, et cetera, et cetera, et cetera. So the field is rapidly evolving, raising opportunities, yay, and frankly, ethical considerations along the way, right? Which is interesting. Now, here are some definitions, and I wanted to give you a one-page summary of kind of definitions that we are working with. I don't need to go through all of them, but I'll try and touch on them quickly. Artificial AI by itself, as I mentioned, this is the broader concept of machines being able to carry out tasks that we would consider, smart, or that may normally require some human intelligence. As an example, AI in healthcare. It can now analyze medical images that help diagnose diseases and cancer. Systems like IBM, I think they have an IBM Watson, it can help doctors make treatment decisions by processing vast amounts of medical literature. So it's an exciting field. Machine learning is something I wanted to touch on definitionally. Machine learning is a subset of AI, and it frankly involves uh, the development of algorithms that allow computers to learn and to make decisions based on data. So, Netflix, for example, will use machine learning to recommend shows and movies based on your viewing history. The system learns from your behavior or other users, and it basically then wants to predict what you might like to watch next. That's interesting, and that prediction is a key to it. Now, neural networks is another form of AI, and this is also a series of algorithms that mimic, but this time we're mimicking the operations of a human brain. And what neural networks are trying to do, like the neurons in our brain and the neural networks there, is to recognize patterns and to solve problems. So it's incorporating machine learning, but it's going further, right? And so a neural network, by definition, is the foundation, the starting point for these deep learning modules that will become so important to us in the future of AI. As an example, neural networks are used in facial recognition systems, where they can identify faces by learning and recognizing features such as the distance between the eyes, the shape of the jaw, etc. Other forms include generative AI, right? This is referring to AI systems that can create new content, such as text and images, etc. We use generative AI when we use Chat GPT, for example, or DALL-E is another one, right? Which can generate a lot of images. Chat GPT, if you've used it, you know it can generate human-like responses. We also have to consider in this overall process LLM, or large language models. And large language models are a part of this architecture in generative AI, right? Because AI is trained on these vast amounts of data to understand and generate and manipulate our natural language to give a response. As I mentioned, ChatGPT is a generative AI that will use large language models in its interaction process. It can generate those texts using the language it understands. It can translate, it can summarize content, and more. Anyhow, you can read the rest, pause this, and enjoy. It's a great big world out there. Now, in terms of artificial intelligence, I wanted to just touch on a distinction between discriminative AI and generative AI. So we have this discriminative AI, which is an AI model that's going to focus on distinguishing between different classes or categories of a data set. And so these are primarily used in the classification of certain tasks, right? If I have spam detection on my email system, this is likely a discriminative AI approach, right? There's this discriminative AI model. It's going to use some vendor machine learning, and it's going to be trained in what spam or not spam, right? Sometimes what's spam by the machine is wrong. And I will remind clients, oh, if you didn't get my email, check your spam folder, right? But it's a work in progress. Discriminative AI. Image classification would also be another form of discriminative AI. Now, generative AI are models that create new data. And these new data instances are similar to the training data they were fed, but they can actually develop new content, right? And so with ChatGPT, for example, that's a generative AI model. It can generate coherent and just contextually relevant text based on your given prompt. So you could ask it to write for you a short story about a space adventure, and it would generate that story. So this slide is really just about understanding discriminative AI versus generative AI and their uses in our world today. Now, machine learning is an interesting concept. And machine learning really is a subset, as I see it, open to conversation, of AI. It's a subset of AI that focuses on building systems that can learn and make decisions based and helping you make decisions based on the data. So, unlike a traditional program, right, where there are specific instructions to perform tasks, machine learning is actually going to learn from the data. It's going to try to identify patterns, and it's going to make decisions with minimal human intervention, right? I think Alexa being an example of that. And so machine learning involves these various touch points, right? There's data collection that has to happen. And when we talk about that, the quality and quantity of data are crucial to a really effective machine learning model. And data can be in various forms: images, it can be text, it can be numbers, time series data, etc. Then, once it collects the data, it has to do data processing in its machine learning model, right? It has to be cleaned up and processed and handled. And if there are missing values, it has to fill them in. If it has to normalize the data or scale it, right? Make categories. And then, of course, you'll have your own model to choose from. You can build your own model in machine learning. You could use linear regression, which is predicting continuous values. We talk about that in a course called Operations Research. Machine learning can do decision trees, which can classify regression models. It can support vector machines, which are used to classify tasks. And it can touch and support neural networks, which I mentioned previously. So anyhow, after you collect the data, process the data, choose the model you're going to use or write your own, then you have to train that model on what is good data, mapping it out, etc. Then there's an evaluation of the data and applying some other parameters. And then machine learning wants to predict. There's prediction and deployment, right? Such as predicting customer behavior or automation of tasks, right, would be an order, or providing recommendations. And then, of course, you have to do model maintenance, right? Nothing stays the same. And so you're always working on the model to make sure it's updated or retrained in its performance along the way. So I'm going to pause there. We'll come back with part 2, AI at a 101 high level.